Hi guys, so a quick product review time again. Today we're looking at this Pro RPE-2323 2-channel power supply. It's originally manufactured by GW-Instek. Costs about $320 or about 250 British pounds at the time of this filming, and around about 6,800 South African rand. Now this is quite a big beast. It weighs around 7 kilograms. It's a fairly hefty power supply. It's definitely not a switch mode power supply. It definitely looks to be a linear power supply. We'll have a peek under the bonnet very soon, but let's quickly have a rundown of its major features. Now this is the 2323, which is the 2-channel version. You also get the 3323, which is a 3-channel version. That version adds a fixed 5-volt output, I think at about 5 amps. And you also get the 4323, which is a 4-channel version. The 4-channel version adds 0 to 5-volt output and also a 0 to 15-volt output. Now this version, the 2-channel version, has 2 outputs. Each output goes from 0 to 32 volts DC, both at 3 amps. But you can also set the outputs to operate either in series mode, where you can get then 0 to 64 volts DC, or in parallel mode, where you can get still 0 to 32 volts, but then get a 6 amp output from this power supply. And at the back you can see it makes provision for 100, 120 volts, 220 volts and 230 volts AC, standard IEC connector, built-in fuse, fan and a little remote control port, which we'll talk about in a while. Now I sort of like the form factor of this power supply. It's not too big, even though it is quite a hefty beast. The outputs are not too close together. They standard, they use the standard spacing, which I'll show you just now. The knobs fairly well positioned, maybe a little bit on the small side. And then of course you've got the set and view button over here, and then you've got your output on off switch. There's only one switch that controls both outputs at the same time, and we'll have a look at how the output voltage ramps up and ramps down when you turn this on and off. But I can hear the people shout at me, "Come on, Tian, turn it on. We want to see what the display looks like." Okay. And there we go. This is really one of the features I like about this power supply. Nice, clean, crisp display. No issues about that. Oh, and you might be thinking, well, hang on. This only goes up to, down to 100 millivolts resolution, and this only goes down to 10 milliamps resolution. That's not really what we want in a power supply, is it? Aha, but this power supply has a little trick up its sleeve. You can actually configure it to add an extra digit resolution to both the volts and the amp scale. So you can go down to 10 millivolts resolution on the volt scale, and you can go down to 1 milliamp resolution on the amp scale. Basically, just turn the power supply off, holding your set view button, turn it on, and now you can select between that mode and the more higher resolution mode. Very nice. Let's just go back to this mode. Now when you first turn it on, the outputs default to disabled. In other words, the output on off switch, that is the default is off, and you can see on the display it shows set. That allows you to first set your voltages and your current maximum current output. So let's just, this one's already set for 5 volts. Let's set the current to, let's say, what's that, 200 milliamps, 200 more or less. And for channel 2 voltage we can set that to 12 volts, and we'll set the current output to, let's say, 1 amp. There we go. Okay, now at this stage there's no voltage present on any of the outputs because this output is not yet turned on. Right, so if I press this button, you can hear the relay click, and now voltage is present on the outputs, and it's actually measuring the current draw and not showing the maximum current. So let's just turn that off. There you can see it says set again. This is the voltages that it's set to. That's the maximum current for each channel. If we turn it on, that now shows it's in constant voltage mode. These are the voltage outputs, and these indicators indicate how much current is being drawn from these outputs. And it's got a very nice protection feature here, a lock button. If you press that and hold it in, it will lock the output voltages. So any adjustment that you make on the output simply will not reflect on the actual outputs of the power supply. Right. If you turn on the output, it remains set, but if you unlock it, it will turn off the output because you might have messed with this voltage. So you can just turn it back and then lock it again if you wanted to. Now if you turn on the output, now there's voltage present on these two outputs, and your environment loses power. So say for instance we turn this off and turn it back on again, you'll see that the output defaults to off. Now that's once again a safety feature, just so that if there's some sort of a power failure or a power dip, that your experiment does not go up in flames, but you might still want that to be on when the power comes back on. And once again, you can configure that on this power supply. To configure that, turn it off, hold on the on-off button, turn on the power. Yeah, off is flashing, and you can toggle the default state of the outputs by pressing the set button. So either on or off, back to on, and then you confirm pressing this button. And now if we turn on the power, the output should come on. There we go, by default. Now one of the features of this power supply, according to its booklet, is that it's got a smart quiet fan, but I don't know how smart it really is. I don't know if you've noticed the actual fan noise. I'm just going to bring the mic a little bit closer. I'm about a foot away from it. What's that, 3 centimeters from the power supply? Let me just turn it off, and let me turn it back on again. It's definitely louder than any of the other pieces of test gear that I have on my bench. It might be a little bit annoying, but we'll have a look at the fan when we open it up and just see if we can maybe do something about that. Now I've adjusted the camera exposure so that the display is being recorded as it looks to me in real life. So once again, really nice and crisp, very well lit. There's no undue hotspot or anything like that. I really like this display. And here I've got it in the configuration mode. There's the standard resolution, and there's the high resolution mode. Right, I'm going to set it to this. Confirm. Alright, so currently I've got it channel 1 set to 5 volts, I've got channel 2 set to 12 volts, and I've got the current limit for channel 1 set to 50 milliamps and the current limit for channel 2 set to 1 amp. Right. You can see it's in the set mode. Output is not currently on, so it just shows what the current voltage output levels are and what the current limits are set to. Right, now I've got my little variable resistance box over here. Let's turn on the output. Now you can see it's actually showing the output voltage and it's showing the current being drawn. Okay, I've got the variable current box set to about 500 ohms, so that's why you see 10 milliamps. I'm going to decrease the resistance, so you can see the current will increase, the current draw, and now we should see it switch once we hit 50 milliamps to constant current mode. Yeah, there we go. Now we've hit 15 milliamps in terms of current draw. It's switched to constant current mode, and it's now limiting the current by reducing the output voltage, which is exactly what you want. It's protecting your whatever your little experiment is going on there, and it will continue to reduce the voltage as I decrease the resistance of the circuit here. Right, so let's just increase it again, and once it hits 5 volts, it should, there we go, switch back to constant voltage mode, and there you can see the current draw is back below 50 milliamps. You can at any time, you can just press the set view button and then it'll show you what the settings are. So it's set to 5 volt, set to a maximum of 50 milliamps, and switch back to the actual measurement mode. It shows you the output voltages and the actual current being drawn. Okay, so something very peculiar that I've just seen. I've got the resistance box set to a large value resistance. I'm just going to steadily decrease it. So you should see 1 milliamp current draw. There we go. Decrease it further, 2 milliamps, 3 milliamps, 4 milliamps. But now here's the peculiar part. It never hits 5 milliamps. It jumps from 4 milliamps to 6 milliamps, and it never hits 7 milliamps. It jumps from 6 milliamps to 8 milliamps and then to 10 milliamps. But from there on out, you see it go in 1 milliamp increments, no problem. Now the handle on top of this power supply makes it a little bit awkward to stack additional components on top of it, so that's a little bit fiddly, but we'll see if we can maybe remove that handle later on. But let's just have a look at the accuracy of the current display here. Let's just turn it on. Oh, there we go. So yeah, 50 milliamps, 50 milliamps. I'm going to adjust the current maximum current output here. Yeah, that's actually not too bad. Very nice. Let's just go all the way to 1 ampere. Yeah, that's fairly accurate. That's not too bad. Especially in the low end, where it really matters. And in terms of the voltage output, yeah, that looks to be fairly accurate as well. Let's just check a couple of voltages here. Yeah, that's actually quite spot on. Yeah, not too bad. Let's just go all the way. There we go, 33 volts. No issue with the accuracy really. Well within specification, and it's pretty much spot on to every reading. Excellent. Now, one of the really important things that you want your power supply to do is when it switches on, it must have a fairly linear ramp up. It must not overshoot on the output voltage when you turn on the output. And yeah, let's have a look and see what this power supply looks like. I've got my trigger level set to what's the one volt, and I've got it set to 1 volt per division, and I've got the power supply output set to 5 volt. So let me activate the output of the power supply. That's a very linear ramp up that you can see over there. Slight bump, nothing really to write home about in terms of overshoot, and then just flat further on. Very, very impressive linear ramp. Okay, let me turn off the output, and look at that. What a beautiful down ramp that is. No noise or anything like that. Just jump straight from 5 volts down to 0 volts, and you've got the capacitive discharge curve on the output there. And just coming back to the activation or the ramp up, let's just have a look at the ramp up time there. If we have a look at the first, let's put it down there, and the ending time, let's put it down there. Yeah, so it's in about 13.4 milliseconds it ramps up to the full output voltage. I'm just going to test a few other voltages quickly. There we go, that's 10 volts, and you can see it sort of retains that linear angle of ramping up the voltage. It doesn't become steeper when you use a higher voltage. It just takes slightly longer to activate the output. Very nice. Again, a tiny little bump right at the at the top, but no issues with that. That really looks quite good. And I've got it set to its maximum of 33 volts. Let's just increase the horizontal time there. and trigger it again. Output contact. Whoop, actually need to increase it a little bit more still. And re-trigger. Contact. There we go. Actually, that's very impressive. And maybe just as one last test, let's turn off the power supply and then turn it on again and see if we still get that same stable linear ramp up. Right, I've got the power supply completely turned off now. I've got the output set to automatically turn on directly after the power supply has been turned on. So let's have a look, turning it on now. Yeah, perfect. No issues with that either. And here it is at 1/2 volt. Still very good. Also supplied with it is a stack of little manuals in all the languages of your choice in choosing. Let's just have a look. Yes, there is actually an English version. And also supplied along with it is this bag of probes, basically crocodile clamps and cables, and CD. We'll have a look at what's on there just now. Here we've got the 2 sets of probes. I'm not too sure what I think about the power cables that come with a power supply. They are definitely nice and is it at least very rubbery. I'm not sure if that's silicone, but they don't have banana plugs on the one end to quickly plug and unplug from the power supply. Now that's maybe a disadvantage on the one side, because you have to screw them into the screw terminals, but of course then the advantage of that is that you can screw them in and you can also plug in additional cables like a multimeter lead or something like that to measure the output voltage of the supply. And the crocodile clamps, yeah, they look to be of a reasonable quality. I'm slightly recessed there. Yeah, that's actually not too bad. So look at the other one here. Yeah, slightly pink though, maybe if I compare it to some of my other leads here, which is more of a red color, but overall really not too bad. Maybe one thing I would really like to see on this power supply is a multi-turn potentiometers. This power supply really is begging for that, especially on the current range where you've got 1 milliamp current resolution. You really want to be able to set that very, very finely, and it's quite difficult to do that with both a small knob and just single turn, as is the case on this power supply. Now, using the remote control port is as simple as attaching 2 jumper lead wires to pin 9 and 10 and shorting out pin 7 and 8. There we go. And now you can control the output by shorting the 2 pins. You disable the output, and by leaving them as an open connection, the output becomes enabled on the front of the power supply. So what's included on the CD? Well, the quick start guide, a soft copy of that, and a very well written manual for the power supply. So what's the conclusion here? Really like this piece of kit. It's an excellent power supply. It's nice and compact. It's an analog system. It's got all the requisite requirements that you would need from a fairly standard bench power supply. It's got the set preview function. It's got the measurement mode. It's got the output control. Really, really well thought out piece of kit. On the negative side, the fan noise might be a little bit loud, and these knobs, yo man, I wish they could be multi-turn pots. But other than that, there's absolutely no issue that I can see with this power supply. In part 2, we'll be having a look under the bonnet and see if we can do anything about the fan noise, and maybe just take a quick peek at these potentiometers. Maybe there's some potential for doing some upgrades here. Well guys, thank you for watching. If you like these kinds of videos, please remember to give them a nice big thumbs up, and I'll continue making them. See you next time.